Welcome to Eureka. I'm Gohar Raza and you are watching Eureka, a program that introduces first-rate scientists of country. Our country has produced enormous number of excellent scientists and they have been the nation builder. And therefore we consider this program to be extremely important. Let me take you to a very sleepy small town of Haryana, Rewari. And near this town, there was an ashram. In this ashram, there lived a family. Father was a teacher, mother was housewife. There was this young boy who was inquisitive. He poked his nose into everything that came across. But he was very dedicated and sincere. And therefore, during the vacations in the school, he never took chutti. Instead, he volunteered himself to the kind of camps that his school was organizing, especially the camps that treated cataract. He looked after the patients during this period. He somehow got interested into making and breaking things. And that is how his interest in science grew. Father and mother encouraged him. And here we have Dr. Chandrasekhar. Welcome to Eureka.
Thank you.
Dr. Chandrasekhar.
Thank you, Gaurav.
When you look back at the ashram period of your formation of your personality, how much did it contribute to what you have done later on in life?
I think it has contributed in a very major way. It was unique in the sense that an ashram is neither a village nor a town. And this ashram was started by a Swamiji by name Swami Paramanand Saraswati. He had a vision for a new India.
For a modern, scientific and technological India.
Absolutely. Which combined the ancient wisdom with the science and technology of modern day and a transformation of the country and society.
He was a modern Renaissance man.
Yes, absolutely.
And he never encouraged superstitions.
Never ever.
Instead of that, he believed in modern education,
Yes.
science and technology, and that he thought would build the nation.
Absolutely.
So the first building block was the younger generation that he was trying to train and pull towards science and technology in the country.
That is right.
But how was your life shaped individually?
Well, the Swamiji had started a school and the school was called Achut Pathshala.
What a name.
Well,
Very, very courageous name.
very, very courageous name for those
Because
times.
the moment you say Achut Pathshala, a lot of people will not come even near that place.
Absolutely. But he insisted on naming the school that way. It was a day school where from the erstwhile or the so-called Achut community, which Gandhiji so lovingly named as Harijans, kids were solicited. And despite all the kind of prejudices in the society and to an extent threats, they were provided protection to take them to their homes, bring them from their homes.
What was the objection
Well,
by the other
society,
castes?
The society in general at that time did not believe that the Harijans should be going for education. So not only...
Why?
I think it was a social prejudice.
It was a social
It was a
prejudice,
social prejudice.
sanctioned by the philosophy.
That is right. It was a social
And
prejudice.
religious,
That is right.
tenets.
It was a social prejudice. It was a social evil, basically. But the Swamiji believed in the equality of all. And so he insisted on naming this day school Achut Pathshala.
Probably this is what is called later on scientific temper by our first Prime Minister,
Absolutely.
Pandit
Absolutely.
Jawaharlal Nehru.
Yes. So he did not mean to segregate these children and start a separate school for these children. All community children would mingle and they would study at the school, but he still
And there was
insisted.
no untouchability practice?
There was no, not at all, absolutely no. And all kids would mingle, All kids would study at the same school, they would have their meals, but he still insisted in naming the school Achut Pathshala. And as you just mentioned, this name was, a scare for many people who didn't want to send
Must
their
have
children
been.
to this school.
You did very hard manual work, which a lot of people from that generation have grown up with. You had to chop off the wood, lakdi katna,
Ji.
pani sar pe lana.
Ji.
And your father and mother also did the same.
That's right.
So did it not hinder your studies?
Not at all.
How did you cope up?
Not at all. Actually, it looked fun because everybody did it. So you also did it. And I realized in later life, it helped build my self-confidence that I could do all of these kind of things. So it was really not a hindrance. Today, looking back, you might think that this was harsh life, but this was life and we all did it. And our confidence grew because we could do all of that self-help.
And it is because of this probably that you also learned how to work with hands.
Absolutely.
And that gave you advantage over many others probably, that you could with confidence use your hands
Yes.
and do a lot of things.
Yes. One thing that the ashram life taught me was kind of self-help, being confident of oneself and not thinking anything below dignity.
Do
Trying
you
to
still remember that you made a horseshoe magnet out of a nail after winding this thing?
Oh yes. Oh yes.
Do you still remember, and how thrilled were you
I
when it worked?
I absolutely remember.
The electromagnet?
First time in the school when we were taught about electromagnets. I don't remember, it was class 7th or 8th. So I thought I should do an experiment. Just reading in the book was not good enough. So I took a big nail with a big nail head.
Right.
And bent it with a hammer and gave it a U shape. And then I wrapped a electrical wire around it and then connected the two ends to a battery, which I took out from the torch. And I was, thrilled to see that it could lift what was called an आधा पाव weight, which was an
आधे
iron
पाव
weight.
का
आधे पाव का वजन उसने उठा लिया.
Wow.
That's approximately 100 grams.
And that was your moment of eureka probably. that you have
Absolutely.
done it.
Absolutely. So I called everybody, my parents and my friends, and I showed, look, here is something, and see, it can lift a magnet.
That was the beginning of a scientist and a technologist. I have to take a break. We'll come back. Welcome back. We were discussing with Dr. Chandrasekhar what shaped his life as a scientist. So from this horseshoe magnet, which you made as probably 7th or 8th standard student, you've come a long way. Designing something for PSLV, the sensor. How do you look back? You come to Punjab University, you do your BSc and Masters and then go to Pilani. It's a long journey from a simple ashram to ISRO. How do you look back?
Well, I was, as I mentioned, always interested in knowing how things worked and also trying to put things together so that they actually work. And
When did you get interested in electronics?
my electronics interest basically developed when I was a student at BITS, Pilani. And
It was a very new area.
it was a very new
It was
area.
completely underdeveloped area as science. We did not know much about it.
That's right. In the country, it was a completely new area. And I had been a student of physics with electronic specialization. And even there, I was specializing in semiconductor electronics. And semiconductor electronics really excited me because I realized that every device that you make in electronics, all this...
So you didn't like those big tubes, etc., and transformers. You were interested in semiconductors, which was a new area.
I was interested in semiconductors because it was a new area and it had a lot of promise. So I thought I should work in that
And
area.
you were right.
Yes, I was right. It turned out that
To
way.
be very promising area,
Yes.
and it has now changed the world.
Yes.
But at that time, did you realize that India will do good or bad, or it's necessary and for the development? What was it, the motivation? It was personal interest in a new area, or you thought that nation will get benefited?
It was actually both. It was personally, as a student of science and technology, it was very challenging. All these new developments that were taking place, I was very curious to understand how these things are done, how these chips are designed, how they are fabricated. And I also thought that these things are extremely important from our society.
I remember the books initially started talking about NPN and PNP, semiconductor, chips, silicon, holes and electrons,
Yes.
jumping, movement.
Yes,
During that period.
that's right.
So there was hardly any scientific material, text available. Why did you choose such a difficult area?
Well, the primary motive was that it was considered to be important. And it was, already there was this feeling at the back of the mind that this is something which would be really important and it would be revolutionary. And so it had to be done. Difficult or not difficult, you needed to do it. And it offered a challenge. So
And scientists pick up the challenge.
scientists pick up the challenge. And here there was challenge as well as an opportunity to do something good for the country, bring in a new technology.
When did you decide to join CSIR?
Well, I had been a CSIR Junior Research Fellow for my PhD at Birla Institute of Technology and Science, Pilani. After submission of my thesis, I moved over to CSIR Central Electronics Engineering Research Institute, CERI, which is in the same town, just across from BITS, Pilani. And
It has a lovely story of how CSIR decided to, or Pandit Nehru decided eventually to give this institute to Pilani.
Yeah.
Would you like to tell about that?
Oh, yes. See, Pilani was a small, isolated place. Its only distinction was that it was the hometown of Birlas. And they had a Birla Engineering College at that time. And when different CSIR laboratories were coming up, Mr. G.D. Birla asked Pandit Jawaharlal Nehru, the Prime Minister of that time, that he would like to have an electronics laboratory in Pilani.
And that was what was demanded by the faculty of his engineering college.
That is right. The principal of the engineering college had advised him that he should ask for an electronics laboratory.
You enter as a very young, fresh person into a lab of Council of Scientific and Industrial Research, which is Central Electronics Engineering Research Institute. Now, here is an institute which is newly built. It's not very old when you enter. And there was hardly any literature available. So how did you begin your research?
Well, I have the memory that I chose CERI over 2 international postdoctoral fellowships. And that is thanks to the personalities of 2 of the scientists that I met there. So Dr. Khokle, who is one of my mentors, he was heading the semiconductors division. And when I went to discuss with him, it was such a pleasure. And he invited me to join the laboratory. And he, in fact, took me to the then director, Dr. Amarjit Singh, another great personality.
Right.
And meeting him was again a pleasure. And I immediately made up my mind that
I'm not going abroad.
I'm not going abroad.
I'm going to serve here.
I'm going to serve here because I have such excellent mentors here. And we should do something there for the country, staying in the country, working within the country. So I instantly decided to stay there.
And that feeling and that decision probably was rooted in your ashram days.
Yes, indeed. It had something to do with that, the spirit of self-help to, trying to change or improve or contribute to your society by working for it and being within it.
We'll come back. Don't go anywhere. We'll come back soon. Welcome back to Eureka. Dr. Chandrasekhar, when you joined as a young scientist, CERI Pilani, then the institute must have been in its nascent stages because the area itself was in nascent. Today, India is known for good work in electronics. We have not done very well with manufacturing, but we have done elsewhere. Now, how do you look back and see the growth of electronics, area of electronics in the country?
See, as a young person, I was asked by the then director to look at this emerging area of chip design. That was completely new area in the country in 1979. World over, that explosion of electronics was taking place, and the word very large
Especially
scale,
the integrated circuits.
especially the integrated circuits. And the terminology then was large-scale integrated circuits. Subsequently, it became very large-scale
Yeah,
integrated
very
circuits.
large and then now ultra large.
That's right. So, Dr. Amarjit Singh, the then director...
For a layperson, it doesn't make sense. What is the difference between large, very large, extra large,
Okay,
ultra large?
this depends upon the number of components, which are primarily transistors,
Right.
that you integrate or interconnect together in a chip. A
Transistors and diodes.
transistors and diodes, but mostly these are
Mostly
transistors. So you have a thumbnail size silicon chip on which today you integrate upward of 1 billion transistors. And
Right.
this number has changed.
It's been growing.
It has been growing. Every 18 months or so, the number of transistors that you can put on a chip has been doubling. And this has been popularly known as Moore's law. This is because the size of the transistor, individual transistor, is shrinking. So you can lay out or
From
you can put
this
more.
big, which I remember,
Right. So you can put more and more transistors and interconnect them in a single piece of silicon, which is the size, as I said, roughly of the thumbnail. And that number really is astounding now. It is multiple billions. So whether it is a cell phone or it is a computer or anything you carry has these integrated circuits.
no, when we come to these specific tasks, such as providing sensors for PSLV or launches,
Yes.
or satellites, when we come to even sensors for identifying mangoes, as Siri has done, or sensors for identifying various kinds of materials which you have developed, we are very good at it. But for mass production, the country has lagged behind.
Yeah.
What is the reason? Why did it happen? Where did we go wrong?
Okay.
China, Korea, Japan, all other countries which were probably not as advanced during that period have taken over.
Let me explain that. You have, on one hand, you have semiconductor-based sensors. On the other hand, you have semiconductor-based integrated circuits. Now, both these technologies require a lot of design effort, very skilled engineers who can do the design properly. And then you require very expensive fabrication facilities, which are very capital intensive, for actually manufacturing them. Now, in our country, we have done rather well in terms of design engineering, because the design discipline is very highly technical, but the capital intensivity is not there.
Right.
From that side, it looks almost like software.
Right.
So you use similar
We
tools.
were always good in software.
You use computers and you use software to do the designs. The rest is human skill, and we have been good at that. So that part has been very strong in our country. But the manufacturing requires very capital intensive. So, for example, a modern...
We have never been able to invest that kind of capital for manufacturing.
That's right.
And therefore, we depend on other countries
That's right.
for manufacturing
Yes,
sector.
yes.
But as far as software is concerned, we are one of the best in the world.
Yeah, software and design.
Right.
Hardware design. Hardware design is somewhat like software in that sense.
But we have also done very well in hardware design and manufacturing when it comes to specific areas. Can this be taken to a larger scale production?
The cost issues would be there, because if you look at the electronics business, there is this cost intensive manufacturing facilities for semiconductor devices and chips. And then you have systems which integrate these. The system design and development is specific to the products for which you are making it, and the cost intensivity is low. Whereas for chips,
And the products keep on changing,
And the
so
products
you
keep
have
on
to
changing.
keep on investing.
Yes.
It is not one-time investment which will bring you the results.
right. So we
You
have
to
been
be
we
on the
have
move.
been fairly decent in terms of electronic systems, and in the areas of strategic electronic systems we have done well. But at the core component level, where there are chips and sensors, the cost of productions are extremely high, and we have not been able to make those kind of investments.
You grew as the institute has grown. How many people have gone to industry and how many people have come from industry? And you have got a very good linkage, at least with Siri, the Birla Institute of Technology. But do you have forward linkages as well?
We have been working in the area of strategic electronics and some parts which are, I would call them societal electronics, both those. In the strategic electronics, we have a very strong linkage with all the strategic sector institutions, which includes the
DRDO,
Bhabha Atomic Research Center, and various ISRO institutions. Now, there is a very strong tie-up because you have a clear-cut objective that you need to achieve, and you work in that direction. You try to harness scientific understanding and technology to kind of make those projects successful
Right.
and deliver products to them.
Right.
So that part has been done extremely well.
and you have no other go.
You have no other go because you cannot buy that technology, and that technology is not available to
Nobody is going to give you that technology, and if a project has to be completed, it has to be completed.
It has to be completed. So in the area of very high power microwave tubes, in the area of sensors, that has been very, very true, and we have been working in those areas. The other areas are where it is, societal electronics, as I call that. I'll give you an example. An example there is we have come up with a synthetic milk detection system,
Right.
which is based on an electronic tongue.
Which is very popular in the country now.
Yes. So it is based on electronic tongue, and it can discriminate and figure out whether there is synthetic adulteration in milk. So those kind of success stories are there in the societal.
And also identifying problems with the mango.
Yes. For example, the mangoes which are exported, the Alfonso mangoes,
Especially Alfonso, yeah.
they can have a seed weevil, or they could have a spongy tissue, which make them unfit for, your consignments get rejected.
Right.
So we had a X-ray imaging based system, something similar looking to the baggage scanning equipment,
Okay.
but with the automatic image processing to detect whether or not the seed weevil or the spongy tissue is there. So you could segregate mangoes, and it adds value to the mangoes.
Siri Pilani has shaped you, and you have shaped Siri Pilani. As a director, your services in the country have been recognized. You've got lots of award to your credit. Did they help you do more, or they came in the way and you? It was just like that.
Given my upbringing and the ashram effect, I really wasn't chasing awards, but I was chasing knowledge and harnessing of knowledge for social benefits. Those things were uppermost in my mind. So the awards came, it looks nice. It certainly
It gives you a feeling that
Yes.
your work is being recognized by
Yes.
your peers and your
That's right. It gives
fellows.
a good feeling. But I was
never have been the objective in
That's
your
right.
life.
Absolutely.
Would you like to give a message to the younger generation?
I would say go after what you love. Put your hands where your brain is, and put your brain where your hands are. So this, symbiotic working of the hand and brain is extremely important. And don't be afraid of failures. Very often, because of criticism or fear of failure, holds us back. So don't be worried. Don't be held back. Every failure is a learning opportunity. We all have had our shares of failure. It's a question of how we take that failure. So go ahead, learn, work, and set yourself an objective which is bigger than just yourself. Something which is, beyond your narrow self. Set up a larger objective and chase it with all your might, put all your energies, put all your abilities behind it. I can guarantee that you would be happy, and you also would be successful.
Thank you very much, Dr. Chandrasekhar.
Thank you, Gauhar. It has been a pleasure being here.
Do not be afraid of failures. Put your brain where your hand is. That is the message Dr. Chandrasekhar leaves with us. I'm sure the session has been extremely inspiring for the younger generation. We'll come back with another outstanding scientist of the country who has shaped the country over the past 50, 60 years. Keep watching Eureka.